So today we're going to talk about using aspects with ZIO and the ZIO environment. So to start off, we're going to talk about aspects in a couple specific libraries in the ZIO ecosystem, ZIO Test and Caliban, and we're going to see how aspects there provide some really nice functionality for the users of those libraries. But then we're going to step back from that and say, well, what's common between those features, and is that just something special to those libraries, or is there something we can take away from that that maybe we can apply to writing our own code? And to do that, we're going to talk about a programming paradigm called aspect-oriented programming, and we're going to see both some of the problems they identified and the approaches they took to it, as well as the limitations of some of those approaches and why that isn't a major paradigm that most of us are using today. And then finally, we're going to see how with ZIO, and in particular ZIO's environment type, we can actually overcome a lot of those limitations and use these aspects in a way that can really help us make our code more modular and easier to understand. And we're going to finish up looking at some ideas of how we can use this idea of aspect-oriented programming with this new power more broadly, and how this is something you can actually take into your own code and try this out today and tomorrow with your own data types. So to start off, let's look at a couple of these libraries that are using aspects today within the ZIO ecosystem. So one of them is a library called ZIO Test, which is a testing library for Scala, and particularly for functional code. And the distinguishing feature of ZIO Test is it treats every test as a first-class value. And so you can compose tests, you can retry tests, you can do everything you would do with tests that you would do with any other type of ZIO effect or any other value. And so you get a lot of things for free with ZIO Test that would be hard with other testing frameworks, in terms of being able to interrupt tests that are still running, that are taking too long, in terms of getting resource safety if you need to open a database and make sure it closes no matter what, in terms of using the ZIO environment type, and even in terms of having integrated property-based testing. But one of the things that people like most about ZIO Test is this feature called test aspects. And so this is just something that modifies some feature of how a test is executed. And you apply these aspects with this @ syntax. So you could have this test, it could be any test you want, and you put @ timeout 1 second. And if that test takes longer than 1 second run, that test is automatically going to be timed out. And there are a whole wide variety of different test aspects that you can use. I like to joke, it's like one of those Apple commercials where there's an app for that. There's a test aspect for that for just about any question I get about how to do something within ZIO Test. So just to give you a couple of examples, there's an aspect called diagnose that says if a test is taking too long, if it's not terminating, then it's going to time out the test and then print out a localized fiber dump of every fiber that was involved in that test, what that fiber was waiting on, what the parent fibers of each of those fibers were. So it really helps you diagnose an issue of, if you say, hey, I thought this was supposed to be terminating, why isn't it terminating? This is going to give you the information to figure out why. We've got another one called JVM only that only runs a test on the JVM. So we usually try to write code that works on a cross-platform basis, but sometimes there are differences where something only makes sense on a JVM versus JavaScript, something involving blocking, or there's just some difference in the functionality, or we want to test that JVM specific functionality. So you just stick that @ JVM only after that test, and that test is only going to be run on the JVM. We've got a really nice one called non-flaky that just runs a test a bunch of times to make sure the test is stable. So you can imagine a lot of times when we're dealing with concurrency and concurrency bugs, it works most of the time, but sometimes it doesn't. And that sometimes it does not work.
Sir,
Yes.
Adam, so sorry to interrupt you, but I'm seeing here in the question side that some people can't see the slides. I don't know if it's happening with everyone because I can see them.
Oh no, I'm so
guys,
sorry about that.
yeah, maybe you can post if like who can see. Okay, Amit can see, Andrea, okay, because some people cannot, and I'm not sure what the. Okay, yeah, most of them can see. All right.
If someone was having trouble seeing, is it working better now? I was doing full screen on my computer, but maybe that wasn't working for people.
Okay, they can see. Everyone is responding that they can see. Sorry for the interruption.
Nope, no worries at all. We'll do it this way. So this non-flaky one is really nice that if something works 99% of the time, that means 1% of the time it doesn't work, and that's not going to work for us at all. So this helps us really identify that in our tests, and when we think we fixed it, we can really make sure we fixed it by making sure we run it a bunch of times and it still works. We've got another one called tag that just lets you add arbitrary tags for reporting. So you could say, this test is about interruption. This test is about the database. This test is about configuration. And then when you're looking at reporting for it, you can group by that and analyze that. We've got one called time that just times how long each test takes. You can see if there are some tests that are really slow that are driving the majority of your testing time, if tests are taking a long time overall, and say, oh, is there a way we can make that test a little bit faster? Maybe we don't need to be running it so many times or testing with such large generated values, or there's something else we can do there. And then we've got that one we saw before, timeout, that just times out a test after a certain amount of time. And one of the really nice things about these aspects is that they compose. So I can just put these together one after the other to add different types of functionality. So here I'm saying, well, I've got this test. I want to run it no matter what, but on JavaScript, I'm okay just running it a single time. On the JVM, I want to run it a large number of times to make sure it's stable. And then no matter what, I don't want this test to take more than 60 seconds. And so that relatively complex logic, I can describe in this really simple way by just composing these test aspects one after another. And then we can also see, like with this JVM aspect, we can even have aspects that take other aspects as parameters. So this JVM aspect is saying, whatever aspect you put in here, only run it if I'm on the JVM. So in ZIO Test, this is probably one of the most popular features I hear about from users, is people really like working with these test aspects. So from there, let's turn to another library that also uses some type of aspect, and that's one called Caliban. So that's a library in the larger ZIO ecosystem that focuses on providing a solution for doing GraphQL. And it's got a really nice interface where it'll automatically derive your data types from your schema, so you don't have to kind of write all these case classes yourself. It's powered by Magnolia, so it'll kind of produce all of those for you. It's got parsing and validation built in, and under the hood, it's powered by ZIO, so you get a lot of those same features we talked about in terms of being able to use the environment type, interruption, and so on. One of the features that Caliban added is their concept of aspects, which they call wrappers. And these are things that modify some part of how a query gets parsed or gets validated or gets executed. And so here we've got an example from the documentation for Caliban, where we start off with this just GraphQL. This is actually defining our API. And then by applying these wrappers, we're able to specify a lot of specific aspects of how this is actually going to be run. So we're saying we don't want to support more than a max depth of nested queries of 50 nested queries. We want to time this out after 3 seconds. We want to print a warning if we have any queries that take longer than half a second. We want to apply tracing and caching based on Apollo's protocol here. So we're able to add a lot of features to this GraphQL API we've defined in a very composable and modular way, where we could pick and choose any of these and just take these out, and we're going to get a new API that is exactly the same, except doesn't have this, or has a greater max depth than this, or a lower max depth than this. So again, it gives a lot of flexibility to users and seems to be a feature that people really like with Caliban. And so, okay, we've looked at these two different examples with ZIO Test and Caliban, where this seems to be a nice feature, but so far it's just kind of a feature of these two libraries. Like, okay, we can say this is great. If we're using one of these two, we should use this. But what do we take away from this that we can do in our own code? Like, what can we learn from this? Is this just an isolated feature, or is there some commonality between these two things? And to start to answer that, we've got to step back to talk about what this idea of aspect-oriented programming is. And with ZIO Test, when we called these things test aspects, was that just a name we made up, or was there a reason that we called them that? And so aspect-oriented programming is this paradigm that was based on a couple of key ideas. And so the first one is that there are cross-cutting concerns that are shared across different parts of our program logic. But then oftentimes we end up tangling those concerns with each individual part of our program, and so we actually scatter that code across our program. And if we're able to factor out those cross-cutting concerns and separate them from our main program logic, then we can make our programs a lot more modular and easier to reason about. So let's break that down a little bit. So what do we mean by cross-cutting concerns? Well, one way I like to think about it is these are questions of how we do something as opposed to what we're doing. So if what we're doing is transferring funds between two bank accounts, the how we're doing it could be what level of authorization should we require for that transfer to take place? How should we log that transfer? How should we record that transfer to a database? All of those are questions about how, and they involve concerns that might also apply to other areas of, we could say, okay, well, how do we want to log this transfer between two bank accounts? But if we're doing some type of financial services application, there are probably a lot of other things we want to log beyond just this one type of transfer. So going back to a couple of domains we talked about before with testing and GraphQL, in testing, we could say the main program logic is the tests themselves. But there are a variety of concerns about how we run the tests that are distinct from that. So questions about how we run the tests could be, how many times should we run the tests? What environment should we run the tests on, right? That's what we talked about before. Of, do we want to run them on just a JVM or only on the CI environment? Or do we want to run them differently in CI versus on someone's local machine? If we have property tests, what sample size should we use for those property-based tests? What degree of parallelism should we use for tests? Should we run these tests sequentially, or should we run them all at the same time, or should we run them in parallel up to some maximum level of parallelism? What timeout should we use for the tests? So those are all examples of things that could be cross-cutting concerns. And we can see the exact same pattern with GraphQL, where the main program logic is this queries that we're defining and this structure we're defining for our data. But there are a variety of concerns of how we run queries that are distinct from that. So we said before, what's the maximum depth of nested queries we want to support? How many fields do we want to support getting at the same time in one of these queries? What timeout should we use? How do we handle slow queries? How do we add tracing or caching if we want to add those at all to our queries? Again, questions about how we do something versus what we do. And then we have this idea of tangled and scattered code when we don't separate out things. So here's an example from ZIO Test. And here we're trying to test this for each par operator from ZIO, which, if you're not familiar with it, is basically saying for every element in this collection, we want to do some effect. And we want to do them all in parallel and then collect them back into a new list. But we want to make sure that the list has the same order as the original list, regardless of the order of completion of these things that we did in parallel. So if I say do A, B, and C in parallel, and C happens before A, the list I get back should still have A, B, C. It shouldn't have C before A and B. And so here I'm just doing a simple test for this where I'm just taking the numbers between 1 and 100. I'm just creating a new effect that's going to succeed with that value. And I'm asserting I get back that same set of numbers between 1 and 100. But then because this involves concurrency, I want to make sure that this is stable, that this works not just most of the time, this works all the time, that I don't have some one time in 100 that really that effect does finish first and now my list is out of order. And so around that, I'm creating this further operator here where I'm saying, do this whole thing 100 times, and then make sure all of these values are true. And if we look at this code, it's okay, but it's not great. It's a little bit messy here with these two different things we're nesting, and the logic's a little bit unclear of when I'm talking about 1 to 100 here, am I talking about what I'm testing, or am I talking about how many times I want to repeat the test? It's not entirely clear. And the other problem we have here is the odds are that if I'm doing this when I'm writing this test, I probably have other tests that I also want to make sure work not just once, but multiple times. So either myself or one of my colleagues or other contributors is probably writing some variant of this in a dozen other places in some test suite for a large project. And they all may be slightly different. Maybe some of them have some different aspect to them of their doing a different size, or they're off by 1, or maybe one has some weird bug to it. And so again, we're kind of creating problems for ourselves of we're scattering that logic of repetition all over our test suite. So here's what the same thing would look like if we separated that out with an aspect. So now we've got this aspect non-flaky here that's handling the repetition of this test, that's saying whatever's inside here, run it X number of times and make sure it passes every time. And it's got a couple of benefits for us. So one is the actual logic of our test is much clearer now. So now, for the fact that we're doing this in code and not in English or whatever a natural language is, this says pretty clearly exactly what we're testing. That I want to take this for each par thing, I want to run it, and I want it to be equal to 1 to 100. Doesn't have any issues of repetition mixed in there. It pretty much says exactly what the quote unquote business logic is of what we want to test. And similarly, this non-flaky aspect here is controlling everything having to do with how we repeat this test. So if I've got 100 other places where I want to make sure some test is stable, I can just stick at non-flaky after all those other places. And I know if there's ever some bug in the way repetition is being done, or if I want to add some new feature to that repetition, I want to record somewhere how many times I repeated tests, all I ever have to do is look in this one place to implement that. So I think when you look at those two pieces of code, you say, okay, there's something here. Like there really was something less than ideal about the previous implementation, and this really is nicer. There's something to this idea of separating out these cross-cutting concerns with aspects. But then we might ask ourselves, well, okay, if we said this is nice, we just saw it was nice, why aren't we doing this all the time? Why am I kind of giving this talk, and why you read John's post about, is he saying this is a type of programming that people don't normally use, but maybe there's a way for us to use it again? Well, let's dive into that. So the way I would think about it is the problem with aspect-oriented programming traditionally is really an implementation problem versus a problem with the idea. So we saw that the pain points that the proponents of aspect-oriented programming identified with having these cross-cutting concerns and mixing them with the main program logic of our code are 100% real. And we also saw how when we pulled those concerns out into an aspect, we were able to make our code much cleaner, much easier to understand, much more modular. But the problem really was with how aspects were implemented traditionally. And to see that, you can really think about it as a problem of information. So to go back to kind of one of the classic examples for aspect-oriented programming here, let's say we've got this method, transfer, that's supposed to transfer funds between two bank accounts. And we're going to specify the amount here. And it's either going to just do the transfer, or it's going to fail with some type of domain-specific error here. And my challenge to you, or really the challenge that the implementers of aspect-oriented programming faced, is if I'm giving you this method, how do you add logging to it so that a particular step in the account transfer process gets logged? And it's a little bit of a trick question, because with just this signature, there's not a way to do it with ordinary Scala, because this transfer function is just a completely opaque method. We've got no way to look inside that and see what's going on there, or see how we're going to add new code to add logging logic to it. And so what the folks who implemented aspect-oriented programming would typically do is they would essentially rely on a metaprogramming approach. So for example, if you used AspectJ, that's one of the major tools for doing these type of aspects traditionally, it had this concept of advice, which was essentially additional code that this aspect framework would insert into your existing source code after the fact. So kind of like a macro if you're using Scala. And there was this own separate language to it of this code could be inserted at what they call join points, which would be either before or after or around some type of method invocation. And then they use these things called point cuts to designate at which specific points within some method you would add this new code. And so it might look something like this, where here we're first defining this point cut thing that is saying, you can almost think about this as like a matcher. This is saying match on any time we call the set method on a count with an argument that's an int and a return type of void, and then capture the account itself that we called this set method on as a variable, and capture that int that was called as another variable. And then this is that advice. This is the actual new code that we're inserting. And so this is saying whenever that point cut matches, then afterwards, do this other thing. In this case, just print out, I set the balance of this account to this amount. And so on the one hand, this definitely did solve that problem. And really I don't think any other way you can solve it if you just have that method signature that's completely opaque and you want to add new code inside of it. You need to essentially do metaprogramming, and you need some way to kind of identify what code you want to add and where you want to add that code. But I think for most of us, especially who are used to programming Scala, it gets a little bit scary for a couple of reasons. So the first one is accessibility, where just probably in my example where I went through those point cuts and this advice, most people were probably not following along fully there, because I was essentially introducing a new programming language, right? At that point, we weren't programming in Scala, we were programming in this aspect J language. And not only was it a new language, but it was in a way a new kind of language where the units of analysis that we were working with weren't traditional things like integers and strings, they were units of code themselves. And it's also this very specialized kind of knowledge and way of doing something where spending time learning how to do things in aspect J is really only useful if you want to do this particular kind of aspect-oriented programming. It's not useful if you want to do anything else. And so I think for most of us, there's a pretty high opportunity cost of we learn more about machine learning, we've learned more about Kafka, we've learned more about lots of different things. And is this really the thing that's going to be high up on the list for most of us? The second problem that it raised was one of understandability. So once we start using these aspects, we can no longer understand the meaning of our code by just looking at the original source code, because now we also have these aspects that are inserting new code into the source code at arbitrary points. And so it's a lot harder we have to really kind of understand both the code itself as well as these aspects to understand what's going on. And it makes the logic of the control flow itself very unclear. It's almost like a go-to statement, except in a way it's a come from statement where we could have some variable that magically gets set to a different value because an aspect came in at this point and inserted new logic that turned x into x squared or 2x or what have you. And then the other issue here is that sometimes whether those point cuts match themselves can be dynamically determined. So we don't actually even know until we start running the program what the actual code is that we're running. And that relates to the final problem, which is that the style of programming can result in code that is less robust and harder to refactor. So for example, we saw in that example with the point cuts that we were matching on calling the set method on a count. Well, what if we do some refactoring and we change set to be set balance? Well, now our point cut is not going to match and our aspect is not going to be applied. And maybe that's going to have a significant difference in our program performing the way we expect it to. And there are a lot of other variants of that probably in reality, we can't just match on the set method on account. We need to match on the set method on account in this package, in this other package, in this other package, in this large application we're creating. And now if we just move this thing to another file in a different package, now this stuff breaks for us. Other problem here is, again, it goes back to this idea we have to have whole program knowledge of both the source code and these aspects to understand what's going on. And finally, if we have some of the stuff being dynamically generated, we no longer have the same level of static type safety that we expect if we're working in a language like Scala. So looking at these things, now we understand that, okay, there was definitely a real problem, there was a real pain point that aspect-oriented programming addressed, but we also understand kind of why people have not broadly adopted this as the solution to those pain points. So how do we start to get past that? Well, the answer we're going to see is in ZIO's environment type and some of the power that it gives us. So stepping back a bit for people who are not already in the ZIO ecosystem, high-level overview, a ZIO is a blueprint for a concurrent program that requires a set of services R and will either succeed with a value A or fail with an error E. And ZIO comes with lots of operators to allow putting different programs like this together to build larger and more complex programs to solve business problems. And for us today, what's going to be particularly important is this environment type R. And that represents the services that a program needs to run. So this might be something like a logging service or a database service. And so it lets us define programs that say this program is going to need some type of logging service or some type of database service. We're not providing it right now, but it's going to need this. And then before we go to actually run our program, we're going to need to provide it with each of the services that it needs. And so there are really two parts of that. There's how do we access the environment to do something with it, and there's how do we provide the environment so we can actually run our program. And let's look at each of those a little bit. So in ZIO, we access the environment using this environment operator, which gives us a new program that just returns the environment, and then we can do something else with it. So here we've got a simple example where we've got a database service we're defining. And we're defining it with what we call in ZIO the module pattern. So we start with this type alias that a database has a database.service. And then we define this service, which here is going to have itself a transfer method that is going to transfer these funds in whatever this underlying database is. And so we can get access to that database to do something with it using this environment operator. So we say ZIO.environment, the service that we want to access, and then we use this flat map operator to continue our computation and to do something with that database. So here we're going to get the database, and then we're going to transfer 100, let's just call it dollars here, from Alice to Bob. And this is an effect that at this point it needs a database. So that's why this database is the value for R here. This is something that's using a database, but before we run it, we're going to need to actually provide it with a database implementation that implements this functionality here. So then let's look at how we would actually go about providing that environment. So in ZIO, typically the way we actually provide one of these services is as part of a layer, which is a data type in ZIO that's used to describe how to construct bundles of services. And so we would have something from whoever implemented this database that would be a live database layer that's going to return a database. And then to get a program that's actually ready to run, we would take that program that needed a database and we would call provide layer with the live database. And now we've got a new program that we can actually go ahead and run because now it has all the services that it needs. And so one of the key ideas of the ZIO environment type that I really want to highlight for you is this idea of deferring dependencies. So the really powerful thing about the environment type is it lets us work with a service without actually having that service yet. And so it's almost like we're writing a check of we get to kind of spend the money without having the money yet. We're promising that before the bank goes to process that check, there will be money in the bank account to honor that check. And so like here in needs database, I'm describing doing something with a database, even though at this point, I don't actually have any database implementation. I'm just saying I need a database implementation, and once I have it, here's what I'm going to do with it. And then I get to wait until later to actually provide some database implementation. And I could provide this live database implementation. I could take this same description and I could provide maybe a test database implementation that just uses a map in memory for testing or something like that. So it's really that idea of deferring dependencies that's where the power of the environment type comes from. So how does all this relate to solving our original problem of addressing these needs of aspect-oriented programming in a way that doesn't require us to use metaprogramming? Well, to take a step forward, let's take that same transfer method and let's now indicate that it depends on a database. So now this method is no longer completely opaque. We still don't know what the implementation of transfer is, but we know that somewhere in there it uses a database. And it could do a lot of different things with a database. Maybe all it does is just call transfer on the database with these amounts. It doesn't do anything else. Maybe it does a bunch of logic before or after. Maybe it actually does this transfer by first doing a transfer in the database from the sender to a bank clearing account, and then from the bank clearing account to the recipient. Maybe it does a bunch of different transactions in the database because it needs to convert currencies along the way. We don't know how many times this database gets called or what else is going on in this method, but we know that somewhere in this method, it's using the methods on this database service. And so now if we want to add logging somewhere here, we can do it by adding logging to those methods on the database service. And we actually do know how to transform the database service because it's part of the environment. So one of the nice features in working with the environment in ZIO is that we can implement new operators that allow us to transform the environment. So for example, we can create an operator, we'll just call this one log, that takes any effect that uses a database service, and it's going to return back a new version of the same effect that logs all transactions with that database service. And there's a nice operator in ZIO called update service that helps us do it. And we can essentially decorate any new service, any service with new functionality this way. And so you can see this is starting to look like these aspects here, where we're taking something, we're returning back the same thing, but we've tweaked it. We've added logging here. So what would it actually look like to do this decoration? Well, here's a really simple implementation of this log method. And so all I'm going to do here is first we're going to access the logging service. And then we're going to call that update service operator that we just talked about. And this here is going to give us the original database. And then we're going to return a new database service that we've decorated, that we've changed its method somehow. And so here, we're just going to re-implement a transfer method. And we're going to call the transfer method on the original database, except now we're going to add this new logic. We're going to use this tap, which lets us just perform some kind of effect after another effect is completed. And all we're going to do is we're going to call that logging service, and we're going to log a new line to the logging service that we're just going to say, we transferred this amount from this bank account to that bank account. And that's going to give us back a new database service. And we can take this farther by generalizing this a little bit to the concept of an aspect. So now we're really in a position to say that an aspect is just something that takes an effect type and returns the same effect type back, potentially adding constraints on the services. So, right, we saw in the previous one, we took something that just used a database service and we returned something that used a database service and a logging service, and potentially adding to the error types. So we could imagine having an aspect that adds new ways that an effect can fail, but it still always returns the same result type. And so this actually really nicely formalizes that intuition we saw before when we talked about ZIO Test and Caliban and the idea of aspect-oriented programming, that aspects change the how, but not the what. So the what is the fact that this effect is returning an A value and can fail with at least an E value. So if I have some effect that's supposed to return a cat, whatever aspect I apply to it, I'm still going to get back an effect that returns a cat. I'm not changing the what of what this thing is doing, but I could change the how. Maybe I say, well, now you should get a cat in parallel, or you should do whatever you come up with. And the other nice thing we can do here is we can then recapture that nice aspect syntax, that at, with just some sugar here. So here we're just saying that for any ZIO effect, we can apply an aspect to it and get back a new effect by doing that at. And we can actually implement these aspects pretty simply by just using those same functions we implemented before to update services in the environment. So here I'm now defining a new aspect that's going to add logging after every database transaction. And my implementation is just calling that same log method that we implemented before. So this aspect is going to take any effect I give it, and it's just going to call that log method, and it's going to change the database implementation that's used by that effect to add logging after every database transaction. And so now, if we put it all together, we can now do transfer Alice Bob 100 at logging to add logging after every database call in that transfer method. And so here now we've really achieved the goals of aspect-oriented programming. Right? We've completely separated the concerns of logging with doing this actual transfer, where we saw that our logging method, or logging aspect doesn't know anything about the implementation of transfer. It doesn't really know anything even about the implementation of the database. It knows that there's some transfer method in the database, but it doesn't know what that transfer method is. It could accept any database you want with any different implementation of that transfer method. It just knows after that method is called, it's gonna log that result. And similarly, this transfer method doesn't know anything about logging. That's handled after the fact by this logging aspect. So we've now got a way of accomplishing those goals and addressing that pain point we saw with aspect-oriented programming, but we've done it with plain Scala and with functional programming, and everything is type safe and composable. So just like with the aspects we saw for ZIO Test and Caliban, if we had other ways we wanted to modify this transfer function, we could just stick those right after it, and those would compose together in a very logical way, where each of these is essentially applying a function to this effect. So if we have this one and then something else, we know we're going to apply this aspect first and then that aspect. So, okay, this seems cool. How do we take this and how do we start to apply it to our own code? And what do we take away from this talk beyond like, oh, that's cool? Well, the first thing that I would encourage you to think about is creating aspects for your own data types. So we saw before that there were test aspects for tests, and in ZIO Test, tests themselves are a kind of effect that just returns a test result. We saw that Caliban has these wrappers that are aspects for queries, which themselves in Caliban are also based on ZIO effects. We saw we had this generalized aspect concept that we talked in the last section. That's just an aspect that transforms a ZIO effect. So I hope you're starting to get the idea there's nothing magic about these, and that any data type you're working with that is effect-like can actually potentially have its own aspect associated with it. So for example, here I just created a new data type for a stream aspect. So another one of the major data types in the ZIO ecosystem is a Z stream, which describes a effectual pull-based stream. So we could imagine using a Z stream to describe a stream of all the tweets about the presidential election in the United States or any other topic that you come up with. And we could create aspects to modify some aspect of how that stream is run or how that stream is executed. And so I kind of challenged you to think, what effect-like types are you using where an aspect might be helpful for you? So it could be Z managed if you're doing a lot of things that are involving resources and managed effects, and maybe you want to change some aspect of how that logic is being handled. Maybe have some custom data type that you've created that's powered by ZIO under the hood. Maybe you're working with the Z pure data type from ZIO Prelude. Whatever effect-like type you're looking at can potentially have its own aspect defined for it. The second thing to think about is, before even going to some of what we talked about in the last section around the environment, what aspects can you define polymorphically? So here I've created this new type alias called stream aspect poly. And this is a stream aspect. This is an aspect that's going to modify a stream, just like we talked on the last slide. And it doesn't require any environment and doesn't add any new ways that the stream could fail. So this is the most polymorphic type of aspect you can have. But even these can sometimes have interesting aspects associated with them. So for example, for streams, one of the questions of how a stream is run is what chunk size should you use? So again, imagine we're pulling tweets from Twitter. We probably don't want to pull one tweet at a time. That's not going to be efficient because there's overhead of pulling these tweets. We're going to want to pull a chunk of every 100 or every 1,000 tweets that have come in on the topic we're interested in since the last time we pulled. And then later on, we may want to change that chunk size for efficiency. We may want to use a chunk size of 1,000 or 500 or 2,000. And that's an operation that doesn't require any environment and doesn't introduce any modes of failure and still returns back a stream with the same output type. So it's actually a perfect candidate for this type of polymorphic aspect. And generally, the more specific a data type you have, the more interesting aspects like this you're going to be able to define, because that data type has more structure around it. So if you think about a stream, there are a lot of aspects to, like, how do you run a stream that aren't applicable to just a ZIO effect or a Z managed effect. So these polymorphic aspects can be an easy starting point as you're kind of thinking about what aspects could be relevant for my data type. But oftentimes we are going to need that additional power, particularly of the environment, because these aspects are so general that if this is literally any stream at all, we can do some things. We can re-chunk it, maybe other things, but a lot of times we need more information than that. And that's really where the environment type comes in. So what I would suggest is think about implementing operators in your domain in terms of services, and then think about defining aspects to transform those services in ways that are relevant for your domain. So here, I just want to show another example of how we could use this type of functionality. We could imagine defining a trait authorization, and it would have some method that lets you get the current authorization level. And with that, we could define another new aspect. I'll call it authorized only. And this will take any database transaction. And if the authorization level isn't at an appropriate threshold, it's just going to immediately fail with an authorization error, and it's not even going to execute that database transaction. And again, that's something that we can just stick around any effect we want to in a composable way like this. So these are ideas for how maybe you can apply some of this concept aspects in your own code. And really, I would think about aspects as, in a way, how to make the environment type most useful for your users. Because when you define something as a service in the environment, you give users the ability to implement any version of it they want. So for example, in ZIO, there's a random service. And by moving random number generation into the environment, you give the user the ability to provide any implementation of random number generation they want, and that'll perfectly plug into everything that happens in ZIO or libraries based on ZIO. Now, that's great, that's a lot of power, but for the average user, they probably don't actually want to create their own random number generation service. That's too much work. That's not what they want to do. And so what's actually going to be most helpful for the user is to give them ways to transform that random number generation service. So you can imagine users might want to set the seed of the random number generation service to a particular value. Or maybe they want this to be non-deterministic. They want to seed it with, say, the system time, so that every time they do it, they get different values. And those would be things where I'm sure different users are going to have different preferences for different use cases. And those are the type of things you can put in aspects to make a really nice API for your users, where it's easy for them to specify exactly the behavior they want for those things, and to also keep that really nicely separated from the rest of their domain logic. So with that, I will wrap it up. To summarize, hopefully you see from this that aspects are tools that you can use in your code today. They're not just things in ZIO Test and Caliban. They're not implemented in some crazy way where ZIO Test has a bunch of macros under the hood doing this. They're plain Scala. They're actually relatively straightforward. They let you separate what you want to do from how you want to do it and make your code more modular. And you can take even more advantage of that by using services to describe the functionality in your application in a modular way, and then using aspects to describe ways of modifying those services that are relevant and helpful to your users. So overall, I think there are some tools that ZIO's brought here that really potentially allow us to use these type of aspects in a significantly broader way than just a couple of libraries that we've talked about today. And I think even out in the wild, just yesterday, there was a library that came out for resilience in ZIO by, I'm sure I'm gonna get the GitHub handle wrong, but it's Runeland. And it has a concept there of a resilience policy, which is also very similar to an aspect here. So there's a real need for something like this. We now really have the tools to do it. And I think it'll be really interesting to see over the next couple of years what people come up with this type of functionality. And with that, I'd like to first thank Commerce Tools for generously sponsoring this event and make this possible. Second, John DeGoes for his mentorship, leadership in the ZIO community, and his feedback on this presentation in particular. All of the ZIO contributors for their collaboration and the work they've done for building ZIO and making this possible. All of the ZIO users, any of you or anyone who's listening later who has used ZIO or given feedback on this was good or this didn't work or I have a question about this, that's really what's helped us get to where we are today. And finally, thank you to all of you for taking your time out of your day and your evening to attend this talk. So with that, I'm happy to take any questions that you have.
Adam, can you see the questions yourself, or should I
can see the questions. Yep, I'm just about to go to the first one. So the first one was, can this test library be used for Scala core code or even Spark code, or is this library focused at projects that use ZIO? So the answer is it can absolutely be used for code that doesn't use ZIO. So yeah, any type of code you have, whether it's ZIO or not, you can use it. If you're familiar with ZIO, you'll probably find more things familiar, but 100% ZIO test is for everyone. So the next question is, how is ZIO environment different than simply adding the service database as an additional argument to the functions? So that's a really good question, and it's really a question of ergonomics. So if we go back to, let's find the implementation of one of these transfer methods here. So here, that's exactly the right point, that we could take this database and instead of having it here, we could just move it as another parameter here. The downside of that is really around ergonomics, and particularly as we scale. Because generally when we have dependencies, we want to provide dependencies at the very top of our application, but we need to use the dependencies at the bottom, at the leaves of our application. And so you can imagine if you just have this as an argument to this method, you're going to have to pass that argument all the way down through maybe 10 different layers of your application. And it's kind of like if you have future code that uses futures and you have like execution context or something like that. Like you at the very top of your application, you create this execution context, and you've got to thread that through every method that you create all the way down to the last one in your application. And so it's 100% possible, but it just gets a little bit tedious, which is why people turn to these alternatives. And the other problem is typically we may not just have a database, we have database and logging and authorization and a connection. And maybe we have different things. We have a Redis service versus SQL versus NoSQL. And in a large application, you may have like 10, 12, maybe more different services. So you can imagine, yeah, you can definitely have you have transfer here, have 15 parameters and take every one of those and pass them down. And you can do the same thing with every method along the way. And I mean, in a way, it's going to be very clear. It's going to be very simple, but I think you're probably going to you're going to be pretty unhappy doing it. And after doing it for a little while, you're going to be turning to one of these other tools that's going to help clean that up for you. So the next question, I'll just read it because it's a little bit long, is the original aspect-oriented programming promise was to add aspects to any part of code, which has a drawback you mentioned. The aspects you're offering here are useful when we have multiple implementations of some service like a database. But if we use most of the time just a single implementation trait, having to implement aspects for each different service isn't just moving some code to a different place with a different structure. And to a certain extent, I think that's true. I mean, I think in a way, the aspect-oriented programming goal was to move things to a different place, that kind of having these things. I mean, if we go back to like the testing example, having that code that logic is still there and non-flaky, right? The need to do something 100 times doesn't go away, but having it in that place and being able to have that be one place where it's then used in a bunch of different places is a lot better from an architecture perspective than having that in each individual source code. So, I mean, I think you're right in a way that we could have just baked in the logging to our database. So just when we wrote one database implementation, we just put our logging logic there. But then we're kind of hard coding ourselves to anytime we use this database, we're also getting logging, which maybe we don't want to do. And this gives us a way to separate that out and make our code more modular. Okay, so next question is the order matters. At logging, at limit 1, at logging, we'll log twice, we'll do the database operation twice. So the order definitely matters, which I would think of as a feature, not a bug. We're never going to do the underlying database operation twice unless we very explicitly intend to, unless we make some aspect that says do it twice. And the reason for that is we're always just calling the underlying implementation. If we apply more than one aspect, we're just calling the nested aspect, which is eventually going to call the underlying database. So we're never going to call the database more than once. But you're right, the order matters. That, like, let's go to the example we had at the end of logging and authorization. So as I've written it here, we're going to apply the authorization first. So we're going to say, if you're not authorized, we're just going to fail this whole thing, and we're not going to even do anything else. And let's say this logging was going to log before the transfer got executed as well as after. Right now, we're saying, if you're not authorized, we're just done. Now, we could also do it the other way around, and we could say, we want to log first, that we're at least starting this transaction, and then we want to apply the authorization logic. And both of those are valid ways to do it. They have somewhat different meaning, and that actually ends up being a feature of this. So like if you go to the ZIO Test example, you can have that timeout operator that times out a test, and then you can have the operator that runs a test multiple times. And you can want to do those in either order. Both of those make sense. You could say, I want to run this 100 times, and I don't want all 100 of them to take more than 60 seconds. Or you could say, I want to run it 100 times. I don't want any one of them to take more than 1 second. And you can implement both of those by just ordering those test aspects differently. So yeah, that's part of that composability. So is the aspect type something that will be included in ZIO in the future? I think probably yes. There are a couple of slight variations on the exact encoding, but I think probably yes. So there's not a framework for it published. You can see it in action in some of these libraries like ZIO Test and Caliban, but I think really the goal of this talk was to try to push the thinking of taking this from something that is a feature to a concept and can then maybe become a framework over time. I think probably the first step would be potentially having some of these data types for things like ZIO. So there's kind of a reference. This is what a test aspect looks like that people can take and apply to different data types of their own. I think over time, there may also be a role in some kind of framework to help just take out a little bit of the boilerplate, where like if we look at this implementation of how we decorate these services, we've got to essentially re-implement the different methods of this service, which depending on how many methods it has, may have a little bit of code that we have to write. That's essentially the trade-off for not having just that like unlimited power to just insert any code in any place. So there may be some things we can do to kind of facilitate that and make that easier for users. how does this compare to using higher order functions? So I think in a way it really is using a higher order function. If we look at this definition of a test aspect basically is a function. It's a function from one effect type to another. So I think this really has two advantages of just a classic function in Scala. So one is that we create this as its own data type. So it's easier for us to refer to it with other things that we're doing. So for example, we talked about before this idea of you could have an aspect that takes another aspect as an argument. That's easier to do when an aspect is its own data type versus just a function. The second thing that is important here is that, at least in Scala 2, functions aren't general enough to describe the polymorphism of these aspects, because a function just says, for one specific A, I'll take a ZIO REA and I'll give you back a new ZIO REA. But an aspect here is actually a polymorphic function, is what they call it in Scala 3, or you could also think about it as like a universally quantified function from more of like a theoretical perspective of, this says for any possible RE and A within these constraints, you give me one and I'll give you back the same type. So there are some implementation differences, but I think the idea of thinking of them as functions is 100% right. Looks like you're specifying aspects as all call sites. Can they be specified at execution sites so that all calls will automatically get them? I want to make sure I'm answering. I'm not sure I fully understand the question there. So generally, aspects can be applied anywhere. And one of the nice things you can do, particularly if you know more about the data type, is that you can allow them to be specified in different places. So like in ZIO Test, one of the really nice things is you can have individual tests, but then you can also have suites of tests. And you can apply aspects to either an individual test or around an entire suite. And if you do so, then that aspect applies to that suite and all the tests within the suite. And so you can actually nest things in different ways, where you can either say, everything in this whole suite, every one of these tests I want to make sure is non-flaky, or you can just take a particular test. You can say, I want to make sure this specific test is non-flaky. Can an aspect then be seen as just a wrapper around the provision service environment implementations? So I would say, I mean, ultimately, in a way, yeah, potentially, yes, at least some types of aspects of, I mean, that's kind of the idea of the decorator here, that this is applying some modification, some decoration to whatever database implementation we're getting using whatever logging implementation we're getting. But I think one of the things that's particularly interesting about this is, at the time we're defining this decorator, we don't know what the database implementation or logging implementation is. So yes, it's ultimately going to decorate whatever the actual provisioned implementation is, but we're doing this at a point where we don't know what that implementation is, and whatever it is, we're still going to apply that logic to it. I see. So that gets sorry, I'm just following up. So there's a follow-up question from a little bit on, looks like I have to write one aspect per method signature. For example, I have to write logging for transfer, another one for debit, and yet another one for credit. And I think that's something that depends a little bit on the data type you implement. So if these are just completely separate methods on just a trait that doesn't have any other structure to it, then yeah, you would implement those separately. But you could potentially create data types that have a nested structure that allows you to apply aspects to multiple parts of them. So that's like what you could do with those ZIO tests, where you nest your tests, and so you can apply an aspect to multiple tests at the same time. All right, I think that's all the questions we have. Well, if that's it, thank you once again so much for your time, everyone who joined me here. I hope this was productive and enjoyable for you.